Hello students and welcome to the next module of reflection of longitudinal waves. First of all, we are going to study the reflection of a longitudinal wave from a denser medium. For this particular thing, we'll need a longitudinal wave first which is incident on a denser medium. So here students, we have a denser medium and the longitudinal wave. Now this longitudinal wave consists of what? Compression and rarefaction. We will study the incidence of a compression on a denser medium. Now students, how are the particle velocity and the wave velocity in case of a longitudinal wave? Let Vp and Vw be the particle and the wave velocities respectively. So the directions are going to be exactly this way. So Vp and Vw will be in the same direction. Now students, when this wave meets the denser medium, it exerts a force on the medium such that the particles are not free to vibrate. What do we mean by not free to vibrate? Student, it is a denser medium. So obviously, the denser medium or the particles of the denser medium will offer more opposition force. So what happens? Despite of the force of the wave, the denser medium exerts an opposite force due to which the wave gets reflected such that the particle and the wave velocity both get reversed. So that is why the resultant force, because of the opposition force, will have particle velocity and wave velocity exactly in the direction as given. Can you guess whether it will be a compression or a rarefaction? Students, the Guru mantra for understanding the compression and rarefaction is: every time the particle velocity and the wave velocity are in the same direction, we are going to get a compression. And when the particle velocity and the wave velocity are in the opposite directions, we are going to get a rarefaction. So here, as both the velocities are in the same direction, we are getting a compression. So students, out of this reflected wave, can I conclude that there is going to be change in phase? So that means a compression will be reflected as a compression and a rarefaction will be reflected as a rarefaction. Now students, let us go ahead and understand the reflection of a longitudinal wave from a rarer medium. So again, we'll consider a wave, a rarer medium and an incident wave which will again have compression. Now students, the same cycle. Vw and Vp have to be marked. It is a compression. Tell me whether Vp and Vw will be in the same direction or not. Yes, they are going to be in the same direction. So here we have our Vp and Vw. Now what happens next? The wave exerts a force on the medium such that the particles are free to vibrate. Rarer medium, obviously the particles of the rarer medium will vibrate with the particles of the wave. Now what happens students? This force which is exerted by the wave does not have any opposing force. So because of the absence of opposing force, what happens next? The wave velocity gets reversed, but the particle velocity remains the same. So students, we are going to have the particle and the wave velocities in the opposite direction. So what do we get? Yes, we get a rarefaction, students. So because a crest is getting reflected as a rarefaction in the reflected wave, what can I say about the conclusion? The conclusion says that there is going to be no change in phase. So a crest or a compression gets reflected as a rarefaction and a rarefaction gets reflected as a compression. So students, the reflection of the waves has been completely discussed, and this reflection of the waves is going to help us to understand a very important concept of superposition of waves. Thank you students. See you in the next module.